So today we are going to cover Chapter 3, Section 1. Today we'll be identifying pairs of lines and angles. The first thing we're going to do is we are defining parallel versus skew lines. So parallel lines are going to be coplanar lines that do not intersect. So there are two lines that run side by side and they will never cross. Then we have skew lines, which are going to be non-coplanar lines that are neither parallel nor intersecting. The symbol for parallel are going to be these two straight lines that go up and down like this. So let's say I told you that this was line J and this was line K. I could indicate that line J is parallel to line K, and you're going to also see on the lines a little arrow indicating that they're parallel. These are not congruency marks, they're just markings indicating that they're parallel. All right, so when I refer to parallel planes, these are going to be planes that do not intersect. So in this particular picture, it looks like a rectangular prism. I could show that the top of my prism, this plane here, ABHG, is parallel to the bottom portion. Now, if they ask you to name it, remember you need to write the word plane and then choose three of the letters that are going around the edges. It doesn't matter. So I could call the top ABH, and then I could say it's parallel to the bottom plane, and I could call that DFE. It doesn't really matter. Pick three of the four letters surrounding that plane. And then I could also have a pair of parallel lines, or parallel planes. I could do the sides. So I could say this left side, I could name that as plane ADF, or AGF, or FGA, and say that it's parallel to that right side of the prism, and I could call that EHB or BCE. It doesn't really matter. Choose three of the four letters. Then I also have parallel planes looking at it from the front and the back. So the front would be here, and again, choose any of the three of the four letters. So I could say it's GHE is parallel to the back of it, which would be over here, ABCD. So I could say ABC. So these would be your three pairs of parallel planes that are going around this rectangular prism. And again, top and bottom, front and back, left and right side. Here are two postulates. The first one is called the parallel postulate. And this one states, if there is a line and a point not on the line, then there is exactly one line through the point that will be parallel to the given line. The perpendicular postulate states that if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. For the parallel postulate, remember the symbol for parallel are two straight lines going down. Remember the symbol for perpendicular is the upside down T. So if I were to draw what I'm reading in the parallel postulate, it says if there is a line, so I'll draw my purple line, and a point not on the line, then there is exactly one line that I could draw through that point that would be parallel to the original purple one. So you can always only draw one parallel line through a point not on the line. Then for the perpendicular postulate, same thing. Draw your one line and then the one point. Then I can draw exactly one line that would be perpendicular to my original drawn purple line. That would be perpendicular. And again, remember perpendicular lines are always indicated by a right angle because perpendicular lines form right angles. There are actually 4 right angles here. Every one of the 4 angles that are formed by those intersecting perpendicular lines, each one of the angles is 90 degrees. The next vocabulary term is called a transversal. And a transversal is a line that intersects 2 or more coplanar lines in different points. So my transversal is this line M that's going down here through that's vertical. My 2 coplanar lines are lines J and K. Once this transversal intersects the 2 coplanar lines, it creates 8 angles. And I've numbered them, 1, 2, 3, 4, 5, 6, 7, and 8. All it's asking us to do right now on this slide is to identify which angles in this picture are interior angles and which ones are exterior. So my interior angles are going to be the angles that are on the inside or in between my 2 coplanar lines. So this is the interior portion of my picture. It's in between the 2 coplanar lines. So this is the interior section. And my interior angles are going to be angle 3, angle 4, angle 5, and angle 6. My exterior portion of the picture is all of the angles that are on the outside of the coplanar lines. And those would be angles 1, 2, 7, and 8. If it helps you to draw a box and like close them in, you could close this up and say, this is my inside section here. And then the other part would be the outside or the exterior. Transversal doesn't necessarily have to be drawn vertically. It could also be drawn horizontally. So for example, I could draw my transversal going horizontally. This is my transversal M. And then I can draw my 2 coplanar lines, J and K. And again, it creates the 8 angles, 1, 2, 3, 4, 5, 6, 7, 8. Notice this time, 3, 4, and 5, and 6 didn't end up in between the lines, so it doesn't matter how you number them. So my interior portion, again, is the section that's in between the 2 coplanar lines, and then the exterior, or the outside of the lines, would include 1 and 5, and 4 and 8. So again, my interior angles, this is the inside or interior, and then the red is the exterior. So my interior angles are 2, 3, 6, and 7 now, and my exterior would be 1 and 5, and 4 and 8. The first special angle pairs are called alternate interior angles. So these are going to be 2 angles that are on the inside or in the interior. They cannot be adjacent, so they're non-adjacent, and they must be on opposite sides of the transversal. So again, let me identify my interior portion. Again, I'm going to highlight it in blue. My exterior, I'm going to do in red. And again, remember the transversal is that line M that's creating those 8 angles. So the first one wants us to identify the alternate interior. So I can already see that my interior angles are going to be 3, 4, 5, and 6. Now, they can't be adjacent, so I can't say 3 and 4. But I'm looking for an angle match, one on the left side of the transversal, one on the right, the way this is pictured. So I have a pair of alternate interior angles with angles 3 and 6. And I also have another pair with 4 and 5. These are my alternate interior angle pairs. Now it wants the same thing, but now it wants us to get them from the exterior. So it'll be between 1, 2, 7, and 8. Again, they need to be on opposite sides of the transversal, and they cannot be adjacent. So an example would be 1 and 8, and 2 and 7. And these would be your alternate exterior pairs. The next special angle pair is called same side interior or consecutive interior. All right, our book calls them consecutive interior. However, be aware that consecutive interior are also called same side interior if you see it on a PSAT or the SAT. And these are two interior angles that are on the same side of the transversal. So again, my transversal is this line going this way, and we could call it line M again. And I'm looking for two angles that are in the interior. So again, this is my interior portion that are on the same side of the transversal. So those could be angles 3 and 5 and angles 4 and 6. Same side of the transversal, but in the interior portion. So 3 and 5 together, and 4 and 6. Now, for the corresponding angles, I'm going to redraw the picture. So I have my coplanar line of J and K. I've got my transversal. And it's going to form my 8 angles. So 1, 2, 3, 4, 5, 6, 7, 8. To find the corresponding angles in the picture, we are looking for two angles in corresponding positions relative to the two lines. So if it helps you to draw a box around the 4 angles that are sitting on, say, line J, and a box around the 4 angles sitting on line K. When I look for corresponding angles, I'm looking for an angle that has the same corresponding spot or position. So notice angle 1, it's up here in the top left corner of the box, and it's going to match with angle 5. So angles 1 and 5 are corresponding. Then I can do the same thing for angles 2 and 6. They would also be corresponding. And then I can also do it for 3 and 7. They're in the bottom left side. And then lastly, I can also do it for angle 4 and 8. They're in the bottom right. Now, another way you can think of these is they're on the same side of the transversal, and one is inside in the interior portion and one's in the exterior. Or also think of it as jumping over one of the angles to get to its match. So angle 1 jumps over 3 to get to its match of 5. Or you could say angle 3 jumps over 5 to get to 7. And the same thing on the other side. However, you'll remember to find the corresponding matches. True and false. A transversal intersects only parallel lines. True or false?
False.
False. Good. All of the examples that we just did, the lines weren't parallel. Now, in Monday's lesson, we will straighten up those coplanar lines and make them parallel, and then we're going to learn about the measures of these special angle pairs. The next one, skew lines are not coplanar. True or false? True, good. Because this is the definition. Two non-coplanar lines that are neither intersecting nor parallel. Part C, if two lines are coplanar, then they're parallel. False, good. They could be in the same plane, but they could be intersecting lines. So I could draw a plane here, and then I can have two lines that intersect. They don't have to be parallel when they're in the same plane. And then the last one, if two lines are parallel, then exactly one plane contains them. And that is true. It's the definition. It says two coplanar lines. So if I have a plane, then the two parallel lines will be in that one plane.
But what if they go into another plane?
So think about the tissue box. If I look at the side and the front, then they're not going to be in the same plane. So the next one, we're using that cube-looking figure to answer these questions. Now, notice it says, think of each segment in the figure as part of a line. So they've already drawn a line on top of CD. However, also any of these other ones, like AB, think of it as a line. So all of these answers, when they ask us to name a line, you're going to pick the 2 points and put the picture of the line on top. So for part A, it wants a line that is parallel to CD. And CD, they've already shown the line here. That includes point A. And point A is here. Can someone name a line that is parallel to CD but includes point A? Good. Okay. And again, the order that you name it doesn't matter. So this one would be parallel, including point A. Now, can someone give me another line that's parallel that doesn't include point A, but would be parallel to CD? Priscilla? Okay, good. So still parallel, but doesn't have point A, could be EF. These are parallel. And then this is what you were asking, could it be the bottom edge of the box or opposite from it? Yes, it could, because HG could also be parallel. And the way that I would draw the plane is I would draw it like this. And it would go diagonally through it. So HG or GH would also be a line that would be parallel to CD. Next, they want us to find a line skew to CD. That includes point A. Can someone find one skew? Good. AH is a line that's skew. Anybody see another one? So he said AH. Skew to that. Okay, AG. Good. Perfect. Would also be skew. All right, part C. Lines perpendicular to CD that include point A. There's only one. Which line would be perpendicular? AD. Good. Now, can someone find another perpendicular, not necessarily going through point A? Good. BC is one. Okay. FC is another. So we have, let's see, what did we say? We said BC, AD, we said FC, one more, and then we have DE or ED. And then the last one wants us to find a plane that's parallel to plane EFG. So plane EFG is the bottom. Which plane would be parallel to EFG?
BCD.
Okay, BCD. Any one of the 4 letters that are going around the top. Could have been ABC, could have been DAB, any of those, or like he said, BCD. Just remember to write the word plane in front. All right, last one. I'm going to go ahead and identify my interior portion again in blue and my exterior in red. So can someone give me a pair of alternate interior angles?
Angle 6 and angle 3.
6 and 3, perfect. Now, the order that you write them doesn't have to be least to greatest. You can write them in either order. So 6 and 3 are alternate interior. Can anybody find the other pair of alternate interior? Yes.
2 and 7.
Beautiful. All right, now we're going to look for consecutive interior. Remember, these are on the same side of the transversal. Anybody know a pair of consecutive interior?
2 and 3.
2 and 3. Anybody find the other pair? So we have 2 and 3. Those are consecutive. 6 and 7. Now we're going to do corresponding. So if this helps to draw the box, there's 4 of them here. Can somebody give me a pair of corresponding angles? Yes, Esteban.
Angle 5 and 7.
Angle 5 and 7. Perfect. Anybody find another pair?
Angle
1 and 3 is another pair. 2 more.
6 and 8.
6 and 8 is another pair. 1 more. Esteban again.
Angle 2 and 4.
Angle 2 and 4. Perfect. And then the last question, a pair of alternate exterior. So we're looking for angles in that red area. Anybody find a pair? There's only 2 of them.
1 and 8.
1 and 8. And 1 more set. Joey?
5 and 4.
5 and 4. Perfect. So in the homework, this is what you'll be doing. You're going to be identifying these special angle pairs.